Today I'd like to talk about events. To help us understand them, we'll first take a look at delegates, which is what events are abstracted on top of. Then we'll see how we can subscribe and publish events, and we'll wrap up by using a lambda expression which will simplify wiring up our event handlers. So events allow a class to send notifications. If a class or an object has subscribed to these notifications, then they will receive these events. This allows for a nice level of decoupling of our code, which is always a good thing. This keeps our code from having dependencies which tend to cause things to break when we refactor. The example we'll use today will be the event raised by the button class within a WPF, a Windows Presentation Foundation type of application, where the button raises the event that's sent to all the subscribers of that event. So briefly, let me recap. When someone clicks on the button, an event is raised. Typically in Windows, events are raised as opposed to being triggered or fired. Each subscriber then will have a chance to respond to that event in whatever way is appropriate. So in this scenario, the button is the publisher of the event, and everyone who has subscribed will be notified of the button click. So let's back up a bit before we continue our discussion of events, and let's make sure that delegates are properly understood. And the reason is that events are layered on top of delegates, so it's real important to understand what delegates are about. So let's move on. So delegates can invoke methods. They are type safe, very similar to, say, a function pointer in C. And they're typically used for callback methods and events. So let's see, the definition of a delegate looks like this. We're defining a public delegate, and we're using the delegate keyword here. The particular delegate here is named log message delegate. You wouldn't have to use delegate in the name. It could just be log message. So we can declare a variable of this type and then point that variable to a method, either a static method or an instance method on some object. And then we can invoke that method through the variable itself, and you'll see how that works in a minute. Now it's important to remember that this type of method we can point to here is one that accepts a string, in this particular case, and returns a void. Okay, so you can see that the delegate definition looks a lot like a method declaration. That's because we're defining the type of method that this delegate can reference. So that's why it looks very much like a method declaration here. So in this case, we have a logger class, which has a method called logMessage, which accepts a string parameter and returns a void, which also is the case up here. So the name of this method isn't important. The fact that it's logMessage is not important. The significant thing is the signature. It returns a void and accepts a message. Returns a void, accepts a message. So this delegate and this method are compatible. So let's look at the rest of this code. We're instantiating a logger, an instance of the logger class here. Then we'll create a logMessage delegate called log. And to initialize that, we'll pass in logger.logMessage, this particular method within the logger class, which is the one we want to reference. We're not actually invoking the delegate here. We're just assigning the method to it. If we were invoking it, we would want to be passing a string value here. But we're not doing it at this point. We're just setting up the delegate. So here's where we invoke the method directly by calling the delegate. And here's where, of course, we pass in our string, which we want logged. And the delegate will call whatever methods it has registered to be invoked. So now let's switch to Visual Studio and we'll see this in action. So, okay, so here we have our delegate example class, and we have our delegate up here where we're defining our delegate. And I want to show you these two classes down here. Both of our logger classes. We have They both have the same message signature. They have a message. In this case, they're both the same name. It wouldn't have to be, but they're called log message. They both return a void and accept a string. And then they go ahead and do a debug write line. And I've just changed this one slightly, so it adds a little text here so we can tell the difference, so we can tell which one is being called. But they're very similar classes. Okay, and let's move up here. Here we have a field, which is our delegate called log. And in the constructor for the delegate example, we create two instances of the logger class. We have the logger, logger equals new logger, and then we have log improved equals new logger improved. We create an instance of the delegate here. Log equals new, and here's the delegate we're creating, and we're going to go ahead and pass in logger.log message. We're not using log improved yet. I just want to show you the creation of it, but we're just going to use the one logger.log message. And then down here we have log. We'll call this log method here and pass in a message, and it will then call the delegate, passing on that message. And then we'll see that it calls in itself a logger.log message. So this kind of a scenario where it could be used in a dependency injection situation where this particular class was passed in a logger and it didn't have to make that decision. Say it was made outside and was injected into this class, and then this class would just go ahead and call the log delegate in that case. So this class wouldn't know anything about where it was logging its messages to. It would be given that. So that's a type of situation that you could use it in. In our case, we're actually creating both of them here because I want to show you how these delegates work. But that would be a scenario which might be something you would do. So the log method is called to log the message. This log method doesn't have to know anything about where the actual log message method rides. We don't want to know which object is going to do the logging or which method within which object does that logging. So you can see this really promotes decoupling of our code. Another thing to point out here is that if you listen closely at the end of the last slide, I pointed out that the delegate would call all of the methods that were registered for it to call. Each delegate is actually a multicast delegate. But actually, before I get into that, I want to go ahead and run this and just show you it working. So let's run. Bring your attention down here. You'll see that we've got this hello printed here in the debug output window. So that indicates that it did call here, which came down and printed the message right here. Okay. Now, I wanted to go on and explain something here. I started to talk about just a minute ago. Each delegate is actually a multicast delegate. So, for instance, what we could do here is we could say log plus equals, and we can actually just give it the name of the function, logger.log message. So we'll go ahead and have it log the same, call the same logger.log message again, and then we'll say log plus equals. Now here we'll use our logger improved, and there we go. And also I want to point out that we can detach by doing a minus equals, and so we'll go ahead and, well, let me go ahead and put this in, and then I'll comment it out. I want to show you. So we'll do another log message. Okay, well, let me comment that out. So what we've got here is we've got the original log message, the second one, so we'll see two of those in a row, and then we'll see the improved. So let's go ahead and run that. Okay, so we have the two hellos and then hello from improved logger, so that makes sense. Now let's go ahead and bring this in where we're removing one of those attached message handlers, And so what we would expect to see is just one of the messages from logger.log message and then one from logger_improve.log message, because we removed one of these, effectively removing this one here. So let's go ahead and run. And you see we just get hello, and then we get hello from improved logger. So you can see it did actually remove one of those here. So it was as if this never occurred. So next we'll cover events, but before we wrap that up, let me see. Yeah. We want to talk about events, but this mechanism is not all that great. We've got this delegate as a private. We could make it public, and then other classes could go ahead and, using this technique, add themselves in. But the problem with this, one of the issues with this, is that someone could actually set this to null. So they could say _log equals null, and it would wipe out any of the other subscribers. And so that's not a great event mechanism. We want a better way to do it. So that's really where events come in, because the only thing you can do with events, the only thing they allow you to do, is to add and remove yourself to an invocation list. You cannot affect the other subscribers. And so that's where events are advantageous here. So let's go ahead and bring events in. Let's talk about events. So when you're working with a class which has events that you can subscribe to, you can simply add your event handler by using the plus equals to subscribe, or you can detach by using the minus equals. And let's see, you can attach both named and anonymous methods. In this example, we have a named method, you can see, because we're actually passing in button _click_1, and this particular handler is named, and we're passing in a name for it. There's also the ability to use anonymous methods, and I'll show you that shortly. The one downside of anonymous methods is that since they aren't named, you can't remove them. There's just no way to refer to them. But in some cases where you're not planning to remove them, it's a nice shortcut way to define event handlers. So we will talk about that a little more later. So here we're creating a new routed event handler delegate and routing it to the button click 1 handler. This event handler then accepts these two input parameters and returns void, you see, and so we'll talk about that more in depth. And this was a particular pattern that you see often in .NET. The event handler is passed the sender object. You can cast this to the type of send object that raised the event. In this case, it's a button object. You could cast the object to a button object and interact with it as necessary. The second parameter is always a class derived from the base event args class. If you ever need to create your own events, you can add properties to this base event class, creating your own class. And these properties would then be available to the event handler that handled your event to help it do its work. In this particular case, if we, since we know this is a button event, we could, for instance, retrieve the mouse X and Y position, the mouse coordinates, if that was important to know. So let's move back to the code now. And let's take a look at how the button is wired up here. First of all, I want to talk about this simple WPF application. We just have a button, hello world, goodbye world, and then we have a text box here, text block. The button is called _button, and then the first one, and the second one is _button2. And then we have our text block, and it's bound to the text property you'll see in this class that I've created. So we just have this little bit of XAML here, which is pretty simple. Let's go look at the code behind. The first thing I wanted to show down here is this message class, very simple class with a text property, text field here. And let's see. I don't want to get ahead of myself. Um, let's see. I want to talk about how the button is wired up to the event handler. So here we have our event handlers. We're adding the button underscore click, the button to underscore click to the actual buttons. Excuse me. Let's see. If we were to take a look at this, let me go ahead and set my cursor on there, and we'll bring up F12. You can see that this is a delegate, of course, and it's the routed event handler. And if we go ahead and take a look at routed event args, you'll see these are the properties of the routed event args class, which, as I mentioned earlier, is based on the event args base class here. Okay, so let's go back. We'll go ahead and run the app, and I want to show you something. Let me save that. Let's go ahead and start. Bring this up. Now I want to show you, as I click here, I don't know if I didn't mention, let's go back. I want to mention what's going on here. Okay, the first button calls button click here, and what I'm doing is I'm setting the message text, this property of the message object, to hello world, and then when you click on the second button, I set it to goodbye world. But now I don't know if you noticed we did this, but when we click goodbye, nothing happens. We click on goodbye world. It should change this text, and it doesn't. And the reason this data doesn't change is that WPF doesn't know that we changed the data in the message object. It has no way of understanding that. It knows it's bound to that, but it doesn't know that underlying data here changed. We need to tell it that this underlying data has changed by raising a specific event that it will subscribe to in order to update the data that's bound to it. So in order to do that, what we'll do is we'll go ahead and we'll implement the iNotify property changed interface. Okay, and let's take a quick look at that. Okay, so here we are. It's a property changed event handler, and let's take a look at that. You see it's a delegate, and the property changed event args. Okay, we basically have property name. So by knowing the property name, then it can go ahead and figure out its binding and redraw the screen, redraw the view at that point. So let's go back and okay, we've gone ahead. We need to do a little more here. Let's see. I'm going to go ahead and do a control period, and we're going to implement this property changed event here. And one of the things we need to do in order to do that is we need a getter and a setter we can work with. So I'm going to change the way this is set up and create a backing variable with underscore text. That's just a private string. And so we've still got our text here we're exposing, and get will return underscore text. But when we set it, we'll of course check to make sure that it's not, that it has in fact changed. And then we'll go ahead and set it, and then we'll raise this event on property changed. And let's go ahead and do a control period here, and we'll generate that method. Now, what we're going to do here is we're going to first see whether property changed is null, because we don't want to do this if nobody's listening. There's no sense in firing this event. And what we'll do is we'll create an instance of our property changed event args. Okay. And then we're going to call property changed, passing in this, which is our object, this instance object, and the arguments. So I think that should work. Let's go ahead, and we've created on property change just so we could use it for multiple properties and just pass in the name of the property that was actually changed. And this way, if you add more items to this message class, they could all be properly tracked. So I think we're ready to go. Let's go ahead and run the code. Okay, and now you see it does change because we're properly firing or raising that event, and WPF is able to figure out what's going on and replenish the view. So let's see, as we talked about earlier, this allows our code to be decoupled. For instance, we can subscribe to the button click event, and the button doesn't have to know anything about who's subscribing. All the button has to do is raise the click event, and it will know that whoever is subscribing to the event will get notified and take the appropriate action. And in our message class, we don't have to know about objects that are bound to this message text property. We just notify anyone who's interested by raising the property on property changed event and then calling property changed. So this gets broadcast out to whoever's listening. So you can see that the button click event and the message text event, these two events are completely decoupled, which helps us create code that's less likely to break. We've removed dependencies that would otherwise have been here. Now, one thing to point out is that the compiler is pretty smart, and it can actually figure out some things here that we don't really have to tell it, and it can simplify our code. So we can actually get rid of this new routed event, and we can just pass in the actual button, the method, the method, it's the way we want called. So let's go ahead and try that, and click Start. And you see it just works just like before. So that simplifies things a little bit. What else? We can actually go a step further and actually define the method right here, up in here, and where we would normally wire up the event handler by using an anonymous method. So let's go ahead and do that. So let's say button click, we can just say delegate and object, and we'll just call it S, and then we want to use this routed event args, and we'll just call that E. I think in this case I've already used E. I'll use E1. Then we'll go ahead and bring this from down here. Okay. Okay, so we've got that, and let's do the same here. We've got delegate, object, S, routed event args, and we'll go with E2, and then we'll say, okay, and we'll go with message.text equals goodbye world. Okay. So now what's going on? Oh, okay, I've got to close those out, right? Okay, so let's go ahead and run this. So you see what we've done here is we've created anonymous methods here by attaching them directly as delegates, and we can actually get rid of these guys at this point. I'll just comment them out. Oops, I was uncommenting there. Let's comment them out. And let's go ahead and run this, see if all works, if everything works. Okay, still works, and we're getting it. It's simpler now. Now, keep in mind that with the anonymous method, we won't be able to detach the event handler because we don't have a way to identify it. But when you don't need to detach your event handlers, this certainly simplifies things. But we can actually get simpler here with link and lambda statements. So one thing we can do is we can remove the delegate. The compiler knows what we're trying to do here. We can actually remove the types because it understands what types are being used. So let's get rid of those. And let's try that. Let's see, compile, okay. Now let's recompile. Oh, I've got to bring in my lambda. Let's just go ahead and do this. I wanted to bring in this lambda statement and show you how this works. So we can simplify things further and get rid of that and get rid of that and go with that. So let's do the same down here. And we're almost there. I think that's right. Okay, let's go ahead and run that. Yep, still works. So let's see. So we removed the return and we removed the brackets, and we're left with a very simple way to add our button event handlers here using the lambda statement. So that's about it for today. I hope you've seen the beauty of using events, how they are great for decoupling our code, and also how we can use the lambda expression here to simplify setting up our event handler. Thanks for watching. See you soon. Thanks.